Good morning. This is Lieutenant Dr. Rahul Mahajan. I am working as an associate professor at Department of Chemical Engineering, Diva Patil College of Engineering and Technology, Kolhapur. So today I am here to discuss about the modes of heat transfer. So heat transfer plays very important role in field of chemical engineering because either the reactions are endothermic or exothermic, and as a chemical engineer, an individual must know how the heat is flowing, what are the various modes of heat, how it is transmitted, and how it is to be utilized optimistically. So, as a first part of the syllabus, the modes of heat transfer, I am here to discuss you about the modes of heat transfer. So, basically there are three modes of heat transfer: conduction, convection, and radiation. So, conduction, it happens in solids. So it can be defined as it is the mode of heat transfer where heat is propagated from higher temperature to lower temperature within the solids without actual migration of the particles. Generally, the heat transfer in this case is transferred from free electrons. So basically it is happening in solids. So this mode of heat transfer has been governed by the law, Fourier's law of heat conduction. So it is giving a mathematical statement: Q upon A is equal to minus K dt upon dx, where Q is the heat content, A is the area, K is nothing but a thermal conductivity, it's a proportional constant, dt is the temperature gradient, and dx with the distance to be travelled by the heat. So here minus sign is always indicating that as distance increases, the temperature also decreases. So this is the tendency. So we can nullify that effect of minus sign by writing T1 minus T2, by writing source minus sink. So this law governs, which is helpful to calculate our heat flux, that is Q upon A. Sometimes the problems or numerical problems can be asked to calculate the thermal conductivity of metal, non-metal or alloy which is used for the heat transfer. Then sometimes temperature, any kind of temperature which is passing from the wall or sphere or cylinder, intermediate temperature can be asked to calculate by using this particular formula or what is the mathematical statement of the Fourier's. So conduction happens in solid, as I told you. Another mode is the convection. Convection is also, it is important mode of heat transfer where heat is propagated from higher temperature to lower temperature within fluids. Convection happens in fluids, it means convection happens in liquids as well as the gases. So it is the mode of heat transfer where heat is propagated from higher temperature to lower temperature within the fluids with actual migration of the particles due to difference in densities. So generally you can come across a lot of hurricanes, tornadoes, whatever the air flow which you can observe in summer days. So it can it is happening due to whenever the surface of the earth is getting heated, the whatever the air which is close to the earth's surface is getting warmer, and it is becoming less denser, and it is just taking away, and that another place is another air is taking place of that air. So that is how the convection is taking place. Now I will just give a practical examples. For example, conduction. Conduction is happening whenever I am going to heat the pot or any material or any utensil. That time heat is transferred from that burner to the pot. It is to the conduction. Whenever I am going to pour the water into it, so what will happen? The water will be heated. First of all, a very small layer of the water, very small, which is adjacent to the bottom of the flask or utensil, it is getting heated. So generally there are three layers: viscous sublayer, buffer layer, and turbulent core. So in that case, viscous sublayer is always heated or warm with the help of conduction, and whenever the heat is transmitted to the bottom layer to the bulk of the fluid, that time the density is going to change. That is how the convection is taking place. So I can say the heating of water is example of the convection. whereas the radiation, same water is giving heat to the atmosphere without coming into the contact, physical contact. That is called as the radiation. So radiation, I will move forward. Before that, I will just let you know about the mathematical expressions or the governing laws for the convection. Convection, it is governed by the Newton's law of cooling, where the mathematical statement is Q upon A is equal to H into bracket Ts minus Tf, where H is nothing but convective heat transfer coefficient, Ts is nothing but surface temperature of the fluid, and Tf is nothing but the bulk temperature. Take an example. I am going to heat the water into the utensil, and whenever the heat is traveled from that liquid surface to the bulk means atmosphere. So that would be the radiation. So radiation, it doesn't require a physical contact. By just electromagnetic waves, the radiation is occur. So radiation is the last mode of heat transfer, which can be defined as it is mode of heat transfer where heat is propagated from higher temperature to lower temperature through electromagnetic waves. So that law or that mode of heat transfer is governed by the Stephan-Boltzmann's law. The mathematical statement of this law is Q upon A is equal to H into bracket T b raised to 4 minus T s raised to 4. So this is the absolute temperature difference, where the sigma is nothing but the Stephan-Boltzmann's law. I repeat, Q upon A is equal to sigma T raised to 4, where we can take the difference in between temperatures. So T raised to 4 is nothing but absolute temperature, 4th power of absolute temperature in degree Kelvin, where sigma is nothing but Stephan-Boltzmann's constant. So this is the these are the various modes of heat transfer which are to be understood practically with the help of example. Unless and until you are not getting the modes of heat transfer, you cannot calculate the propagation of heat, then heat transfer coefficient, heat duty which is required, what amount of heat is evolved by the source and how it is propagated to the system, what is the amount of heat loss. Unless until you are not understanding the governing laws, you cannot calculate the heat loss or heat transmitted from source to sink in effective manner. So in next video, I will just add how the heat transfer coefficient is playing an important role. So basically, heat is propagated from solid, liquid and gaseous, and these three states are existed in the practical knowledge. You must have the idea how the heat is propagated from solid, from fluid and from liquid and gases. So easily we can understand the rate expression for the heat flow by using a Fourier's law of heat conduction as well as Newton's law of cooling for convection and Stephan-Boltzmann's law for the radiation. So this is the very fundamental knowledge regarding what is the heat transfer in chemical engineering. So in next video, I will come up with the more practical videos and the numerical problems regarding the conduction. So conduction can be also happen. Basically, there are three shapes as per our syllabus concern for undergraduate engineering. It is a sphere, then a elongated cylinder, as well as the wall or a slab. So that knowledge an individual or a budding chemical engineer must have, because the rate of heat transfer is always changing from shape to shape. So in sphere it may be different, in cylinder it may be different, and in slab it may be propagated in another way. So thermoconductivity, metal, what are the material of construction is, then ambient air temperature, pressure also, then what are the porosity of material that which can be defined with the help of thermoconductivity, then temperature gradient, what is the temperature of source, what is the temperature of sink, that also matters rate of heat transfer. Along with that, area, surface area plays very important role. So this is how the rate of heat transfer is very important, because without that we cannot calculate how the heat is propagating, how much amount of heat is required. So one by one in my next video I will come up with the heat transfer in solid, sphere, cylinder and slab. The more important aspect regarding the heat exchange equipment is also to be covered by me in another video lectures. So basically I will just brief this session along with modes of heat transfer. First is the conduction, second is the convection, and third one is the radiation. So conduction happens in solid, as I told you. The governing law is Fourier's law of heat conduction. The mathematical statement is Q upon A is equal to minus K dt upon dx, where Q is the heat content, A is the area, K is the thermal conductivity, dt is the temperature gradient, and dx be the distance to be traveled to the heat. So that is about the conduction. Convection, as I told you, Newton's law of cooling is governing this particular modes of heat transfer. The mathematical statement is Q upon A is equal to H into bracket Ts minus Tf, where Q be the heat content, A is the again area, H be the convective heat transfer coefficient, Ts be the surface temperature, and Tf be the temperature of the bulk. So that is how the convection was. And lastly, radiation. It is the another mode of heat transfer where heat is propagated from higher temperature to lower temperature through electromagnetic waves. You can take an example of sun rays which are coming to the earth. It's a radiation. Or whenever you are going to just around the boiler which is fully heated, that time you can sense that heat, so that warm atmosphere. So this is example of the, or campfire you may see. Campfire you may say, when in our winter season we are just using a campfire, that time we are just getting a heat from the burnt fuel through the radiation without coming in thermal contacts, so or without coming in direct in physical contact. So that is the radiation. The law of the radiation is, governing law is Stevens-Boltzmann's law for the radiation. It is coming with the mathematical statement Q upon A is equal to sigma T raised to 4, where sigma is the Stevens-Boltzmann's constant and T is the absolute temperature in degree Kelvin. Thank you so much. I hope you will find this video useful for understanding the modes of heat transfer. Thank you. Bye bye.